People often ask me what browser I'm using because they see it and it looks really different. I've even had people assume that my stream had a crazy setup that wasn't even using a traditional browser, but I am. I'm using Arc. It was not my favorite thing initially, but over time it ended up becoming a browser I quite liked. It's Chrome-based, but its workflow is very different. They've built a ton of cool features on top of it and a bunch of features that I'm not that interested in. But some of those features might touch things they shouldn't. And some hacker, specifically friend of the stream Eva, managed to do some things she should not have been able to. We need to talk about those things, because those things include the ability to run whatever arbitrary JavaScript you want to on my browser, and all you needed to do it was my user ID. Terrifying. This has been a whole thing, and we're going to go through it start to finish, because that's what we do here. Before we do that, let's hear a quick word from our sponsor. This video is about browsers that you run on your computer, but what about the ones you don't? Firebase is here to make running browsers in the cloud significantly easier, and instead of the usual skit, I'm just going to show you how it works. Currently, I'm using the browser-based playground. Right now, it's the default state. I'm going to click run. It's going to run, launch a browser, and show you the contents. But I want to do something different. I want to get the view counts of my recent videos, so we're going to tell it to do that. Go to my YouTube channel and grab the titles and view counts for the last 8 videos. Log them in the console. Now it's going to generate the code to do that work and hopefully show me the results. So here it's created the code. Now it is launching the page. And if all goes well, yeah, look at that. We have the results. Here are the views and the titles for all of my recent videos. By the way, this code is just standard Node.js. You can run it on your own server. In fact, you're probably going to. You just connect to Firebase to do the browser side of things. Tell me that's not super cool. It's never been easier to get data from anywhere on the web. Thank you, Firebase, for sponsoring today's video. Anyways, gaining access to anyone's browser without them even visiting a website. And of course, Firebase was the cause. If you don't already know this about Eva, she is a somewhat quickly growing notorious hacker. Hacked my Notion way back at the beginning of the year, and since then has been on a bit of a tear. The big thing she did earlier this year was destroying almost all of America's fast food chains, funny enough, with a similar Firebase bug, because Firebase's default configuration isn't particularly safe. I'll break down in detail what I mean by that in a little bit. But Firebase hacks are kind of Eva's bread and butter. And it does not surprise me that Arc using Firebase was something she could exploit, because most uses of Firebase are bad, and your browser using Firebase is certainly no exception. So let's break it down. We start at the homepage of Arc, where I first landed. Also, the little kitty running around is very distracting, but very nice for my ADHD brain. Basically, the golden retriever shouting squirrel right now. Anyways, we start at the homepage of Arc, where I first landed when I first heard of it. I snatched a download and started analyzing. The first thing I realized was that Arc requires an account to use. Why do they require an account? Introducing Arc's cloud features. I boot up my man-in-the-middle proxy instance and I sign up. I see that they're using Firebase for auth, but no other requests. Are they really just using Firebase only for auth? After bugging around for a bit, I discovered there was an Arc feature named easels. Easels are a whiteboard-like interface, and you can share them with people, and they can view them on the web when I click the share button. However, there was no requests in my man-in-the-middle proxy instance. So what's happening here? Hacking Objective-C-based Firebase apps. Oh boy. From previous experience hacking an iOS-based app, I immediately had a hunch on what this was. Firestore. Firestore is a database as a backend service that allows for devs to not care about writing a backend and instead write database security rules and make users directly access the database. Oh boy. I'll diagram a bit of what this means momentarily, so if you're struggling to follow, I'll get there, don't worry. This has, of course, sparked a lot of services having insecure or insufficient security rules. And since researching that, I would like to call myself a Firestore expert. I will say Eva's probably within the most knowledgeable people on Firestore at this point. Firestore has a tendency to not abide by the system proxy settings in the Swift SDK for Firebase. So going off my hunch, I wrote a Freda script to dump the relevant calls. So here's a script that grabs all the document with paths, the query where field is equal to's, collection with paths. So this is like grabbing all of the requests being made. Now we're logging the queries directly. Then we're trying to intercept them here too. Fun stuff. Way above my pay grade. Format Firestore data, so she made a formatter so she could actually see it when she logged it. Hacky script, but it works. So I launched Arc with the script loaded on startup, and this is what I got. Now she's seeing all of the things being requested. Sick. Looks like Arc stores some preferences in Firestore, along with a basic user object, referrals, and boosts. So what the hell's an Arc boost? Here's where things start to fall apart. Arc boosts are a way for users to customize websites by blocking elements, changing fonts, colors, and even using their own custom CSS and JS. To quickly show what we mean by this, I'll show you an Arc boost on the Arc site. I hated them at first. I still kind of hate them, but what they're meant to do is allow me to do things like change the page. So if I want this top nav gone because it takes up too much space, zap, now it's gone. Don't know if I can get just this section above, but I think I can scroll it now. Yeah, cool. So the point of Arc boosts is they allow you to customize the site. Maybe you want to change the font. Maybe you want to change the color palette. Maybe you want to hide elements, all those types of things. I don't love it, but others do. It's fine. It is what it is. But in order for those to work, they have to inject custom code on the website. They have to inject CSS for the style changes. They have to inject JavaScript for some of the more complex logic changes. But that data has to be stored somewhere. The code that's being snuck in has to be saved somewhere so it can be snuck in. And that's where it all falls apart. Arc boosts are a way for users to customize websites by blocking elements, changing fonts, colors, and even using their own custom CSS and JS. Do you see where this is going? I've manually logged into my account using my dummy page to test Firebase accounts and executed the exact same query to get my boosts. So this is the query. I'll zoom in. Firebase.firestore.collection boosts, where creator ID is equal to the user ID there, .get docs map, and gets you all of their boosts. So let's create a simple boost for Google. Here, she created a boost just by calling Firebase Firestore collection, where, is that not a create call? This isn't a create call, this is just the get call, but I'm assuming that she had already created it before. Anyways, yeah, there's our boost. Oh, she created it manually. So she created the boost and then is reading it back here so that she can see the new boost after it's been created and see the properties of it. Nice. And in here, you can see the data. If I move the cat, data, JS, alert, JS, zaps, empty array. That's JSON for what it's supposed to do. So if you put custom JS, it would just be embedded right there. Hey, there's our boost. Let's try changing some parameters around. I see that it queries by creator ID, and we can't query a different creator ID than the original. But what if we update our boost so that it has another user's ID? Here is where the problem comes. And here's where I need to break down a little bit about how something like Firebase works. Traditionally, if you're building an API, I'll have my user, make them a circle, because as we all know, users are circles and APIs are squares. When the user wants to do something, like let's say they want to update their username. On a traditional service, you have the user, you have the server, and then somewhere back here, you also have the database. And traditionally, what would happen is the user sends a request to the server saying, hey, I want to X. In this case, I want to change my username. So the user makes the request, hey, I want to change my username. The server uses data from the user's request, things like cookies, to figure out who the user is, make sure it is actually them, and then make a decision based on that. This is all code that you would write that would live in your server. You would have code that's like, let me super pseudocode this, like const user equals await auth request dot headers or something like that. And this is a function that will take the auth data that exists on your headers or your cookies or whatnot, and then return a user. In here, we would put after like if no user, throw new error, unauthorized. So now we know the user's authorized. This type of check, very common. Afterwards, when you want to actually update the user stuff, what you would probably do is use the ID that exists in user. So I would have like db.upsert, update, change whatever you want it to be. And in here, you'd have a query that's like, you could insert, upsert, insert into. There's a lot of different things you could do here, but I'll say, we won't even write SQL because I don't want to confuse non-SQL people. So super pseudo SQL, update name to, we would have the user's request here too. So like part of request would be the new username, const new username equals request dot headers dot get new username. So now I have the new username. You'd want to validate it too. Update to new username where user ID equals user.id. I'm assuming here that you're doing some standardization, stuff like that. The point of this pseudocode is to show what you would write on this server. You first check the user, You then check and validate the thing they want to do, and then you directly update the database using the ID that you just validated. So you only are selecting rows with this user ID, and you're updating them. This is very common. What's important to note here is that all of this logic is code that you have to write that lives inside of your server. That is the code that is doing this. So that code is what will hit the database, make the change, send you the confirmation, and then you send that to the user in the end. This code is not the easiest thing to write. It might seem very simple, and honestly, it is pretty simple. But if you're not used to services, you're not used to servers, auth, APIs, all those things, this can seem intimidating, potentially even unnecessary. So we're going to copy paste this to show the Firebase way of building. I will do my best to not just roast, but that is my instinct because I have strong feelings. So the big difference here is there is no server. The database is the server, which means that we don't have this code or logic at all. Instead, each field has permissions attached to it. So if we have our boosts table, let's say we have table boosts. This table has fields in it. It has things like the user ID. It has things like the actual data for the boost. It has things like the creator ID. It has things like, created at, all of these fields. So the way Firebase works is when the user wants to do something, the Firebase store itself has permissions you've configured for what the user can and can't do. So here, user ID would be attached to user, and your permission would be only people that match this user ID can update your given row in this table. So if a user with a different user ID was to try and update something in boosts, it wouldn't let them. So the rule would be something simple like only users who have a user ID matching a boost can update the boost. And when you're using something like Firestore, usually these things are the defaults. But you can also do things like created at and say locked field. And this field is something that the database would create when you, in this case, create a boost that the user cannot modify. So if the user posts this, they wouldn't have control. Good info from Eva. Creator ID is user ID. User ID is provided by Firestore and request.auth.id. So they don't have a separate user ID on boost. It's just creator ID. Let me double check the dump you had. Yeah, okay, cool. So they don't even have a user ID. They just have a creator ID. But because of that, they're not using the traditional permission model to link boosts to a user. They built their own. So the creator ID is how it ties to a user. And I'm assuming if you were to try and update someone else's boost with a given creator ID, it wouldn't let you unless it was your creator ID. So in this case, the rule would be can't update unless creator ID matches user ID. Pretty common. The issue, if I understand it correctly, and Eva, thanks again, correct me if I'm wrong, is that this rule was only on update. It wasn't on create. So while they might have restricted users from being able to change other users' boosts, they did not restrict a user from being able to create a boost with someone else's creator ID. And here's where it all falls apart. Eva was successfully able to create a boost with a different creator ID. Oh, no, you can do an update. So you can update, if it's your own boost, you can update with another user's ID. I don't think you can update someone else's boost once their user ID has been changed. But again, the problem is the creator ID permissions weren't properly set. So I was able to, in this case, Eva was able to change the JavaScript that is actually backing it. And as such, all she would need is your user ID, and she'd be able to create a custom JavaScript script that would be synced in the Firestore cloud and then run on your browser on whatever web pages it was marked for. Eva confirmed. You can make your own boost and you can update your boost to another creator ID, but you can no longer view or update the boost after you've changed the creator ID. Yeah. So they didn't mark the field properly. This field was used to restrict what you could do to boosts, but this field was not restricted to what you could do to it. This field should not have been updatable. The same way that created at is locked and you can't update the created at field because it's provided by Firestore and the permissions are correct. Creator ID, you can update. And this is the problem with models like this, is when you're not manually encoding what can be updated. Like here, when I did the update to username, I'm only updating name where user ID is this, but the only field that can be updated here is the username field. Where with Firestore, by default, every field can be changed by the user. You have to manually set permissions to prevent these different fields from being changeable. We're going to come back to the article in just a second because we need to start covering the explosion that followed. because it was quite an explosion. This was Eva's tweet: gaining access to anyone's browser without them even visiting a website. Pretty significant exploit. Took them a bit to patch, but they did. But there were some things that weren't great. Specifically, she only got 2K for this. This is an insane exploit to only pay 2K for. And I'm going to both sides a teeny tiny bit. On one hand, this was my reaction. Arc, I love you. Please move the fuck off of Firebase and hire real infra engineers. This is unacceptable. Expecting a public response. I'm filming as soon as I'm home. I'm a day late. Okay, yesterday was chaos. You can do this right. Please do this right. I don't want to switch to a worse browser because you can't build infra. And as Fire and many others pointed out, $2,000 bounty was kind of insulting. So on one hand, I kind of sympathize with them. They're new to this. They have no idea what they're doing. They're a startup. Paying out bounties like this is a new thing for them. None of them are security engineers. But on the other hand, the 2K is insulting. This type of bug is horrifying. They should be reamed for it. To emphasize just how insignificant the 2K is that they originally offered, I'm going to match it. I'm going to pay $2,000 to Eva because it's not that much money and they should have done more. And for her to put that type of work into protecting my browser, the one I'm using, that's worth it to me. So yeah, congrats, Eva. You just made another 2K because 2K was way too little and it's not that much money. So yeah, that's the bit. If I can match the payout, dumb. That said, they did increase it to 20K. As I have saved here, Arc increased the bounty to 20K. We're figuring out logistics for her to get the money. And one of my favorite offers at the end here: thank you for being so patient and gracious with us. We made mistakes. We won't make them again. I'm grateful for how kind you have been throughout this entire process. P.S. You have a job at Browser Company if you ever want it. Very interesting development. I feel like they kind of jumped up and did the right thing here. I don't know how much is them caving to public pressure versus they just didn't actually know. But I think it's important to call out the good thing when they did. I had already mentally committed to matching the money, so I had already done the books and made sure it was fine. That's why I did it anyways. Just wanted to emphasize the point that $2,000 for something like this is not that big of a deal. But yes, they upped it to 20K. I still think it should be slightly more. I hope my additional 2 helps. But yeah, they also did an incident breakdown, and I think this was a pretty good breakdown too. They didn't pretend it was a less big deal than it is. They did call out something important though. No members were affected by the vulnerability, and you don't need to take any action to be protected. Thankfully, it seems like they had all of Firestore's insane logging on, so they were able to write a query to figure out who is affected, and like, if this has happened before. No ARC members were affected by this vulnerability. We did an analysis of our Firebase access logs and confirmed that no creator IDs have been changed outside of those changed by the security researcher. On one hand, huge relief. Awesome that others weren't affected by this. On the other hand, I think this shows just how deep Eva is and how novel the exploits she's finding are, that she's finding shit that literally nobody, not even like a state actor, has done. Pretty nuts. I like they didn't pretend this wasn't a big deal. They called out that nobody was affected without pretending it was not a big deal at all. And that's a hard balance to strike, to keep people from being super scared and dragging your own product while also being honest about the severity of an exploit like this is rough. They did a good job walking the line. They've reached out to me to make sure I knew I could go to them for comment if I ever wanted to. The CTO responded to my tweet: heard you and totally right. We're already working to move off Firebase for new features for the last few months. Full incident rundown here. Any feedback would be very welcome. We want to make sure we set this right. I think they're handling this well, all things considered. They made mistakes. They will continue to make mistakes because they're a company. They're a new company even. This happens. The initial fumble, hard to excuse. The actual security flaw, really hard to excuse. But at the very least, they're doing it right. And on the off chance Eva does decide to take up this offer, they might be well off. Let's finish the breakdown and wrap this one up. Quick recap. Arc Boost can contain arbitrary JS. Arc Boosts are stored in Firestore. The Arc browser gets which boosts are to use via the creator ID field, and we can arbitrarily change the creator ID field to any user ID. Thus, if we can find a way to get someone's user ID, we'd have a full attack chain. The ID is pretty easy to get. Eva actually baited me at the beginning of stream to get mine by asking me for the referral, just to get a referral link, because they have a whole referral system when you invite people to the browser, and the referral includes the data you need to get the user's ID. Great. Then we have publish boosts. You can share Arc boosts, but only if they don't have JS in them with other people. And Arc has a public site with boosts as well as boost snapshots. And all of those contain the user ID. There's also the easels feature, which are basically whiteboards to share things that you're doing on a website, and those also give you access to the user ID. So there's a couple different ways to get user IDs, because without that, you can't exploit. But as soon as you have somebody's user ID, you can go ham. So let's pull it all together. You obtain their user ID, you create a malicious boost with whatever payload you want on their account, but you create it on your account. You update the creator ID, and now when the user goes to that website, they've been compromised. Apparently, it was reported August 25th. It's when they got initial contact with the Arc co-founder, Hirsch. That was TTO I mentioned before. Vulnerability POC executed on Hirsch's Arc account, added to Slack channel after details enclosed, patched within a day, a bit over 24 hours. I'm happy they took it seriously once they were in touch. CVE got assigned about 2 weeks later. All sounds about right. A bit over a week later, actually, regardless. Apparently, you could also run this on Chrome //settings, which is where a lot of permissions are done. So you could exploit permissions, which is terrifying. Yeah. Also, more potential privacy concerns about URLs being sent when you're browsing the web. I've seen a bit of stuff about that with Arc. I think they're working on it, but very happy that these things are being called out and that this stuff is being addressed too. Also, very important, they're doing an audit of their current Firebase ACL rules internally. So hopefully, if there are other things like this, they'll be addressed because they're going to be way stricter about what fields people can and cannot update. Hopefully, they've already went through and checked every single place where a user ID or creator ID is being used. They're also fixing the privacy concerns. They're moving off Firebase. They're doing external security audits for this version as well. And they're starting to use a bug bounty program for further vulnerabilities. Huge. As always, Eva isn't just pwning things for fun. She's making the web safer. This was an awesome breakdown. Huge shout out again to Eva for doing it. Huge shout out to y'all for watching it. And I can't wait until my browser gets hacked again. Until next time, peace nerds.